Hello everybody, welcome to Build or Buy. We got a video we're going to do now. That was a question that was asked of us, and I'm going to go over to that computer and show you the question that was asked on YouTube. And we're going to go to Build or Buy on YouTube, and that was under a test we had done for the AMD WX 7100 and the Ryzen 1800 rendering and Cinebench results. So for Hellaptop, we're going to make this video for you. For those who aren't familiar with the program, SPECviewperf is an interesting, very intensive program, and it took me a little while because we made 6 different changes to our setup before I could get this where the flow and continuity worked for me in our current setup. So what I'm going to do while this video runs, I'm just going to run it as we capture this and put it out. There will be no audio while that runs, but it's a fascinating performance test. And at the end of this, I was going to put a link up to some HTML pages. But instead what I'm going to do is I'm going to go through those HTML pages, and I'll hold the screen there for about 5 to 7 seconds on each one. So at any point you can stop the video and take a look at it and see what's going on. There's a couple of things in here with some of the images that are just pretty wild looking. So we're going to pull this test up and to let you take a look at it. So let's go back over to that computer. Now I've already downloaded the program and installed it. I'll put a link up to it so make it easy for you to find. And we're going to run this test. Now this is running at the 1080 resolution, full resolution. Now I appreciate the question, appreciate the thumbs up, and thanks for subscribing. The only issue I found with it, it didn't correctly identify the RAM in this machine. Because this is a Ryzen, it's DDR4. The test says it's DDR3. But hopefully you'll find this helpful, especially if you're thinking about building a machine. This is what I would consider probably a good bang for the buck right now. I wouldn't build much less than this. I'd build at least a Ryzen, but I would encourage you to build a Threadripper. But my feeling right now is wait on the Threadripper because the new chipsets are coming out. But start getting your other components together. In another video, we're going to talk about some of those components. So let's run this test. So SPECviewperf 12.1. Okay, we're back with audio. Now that you see the results, we are back online, and as you can tell, we'll walk through these 1, 2, 3. Now this is the results of an HTML file. It's on a local hard drive, and it shows us the different tests that were run. The 3ds Max, the CATIA, the Creo, Geophysics Volume Rendering, that's Energy, Maya, Autodesk Maya 2013, Medical, MRI Volume Rendering, Showcase 01, Autodesk Showcase, Siemens PLM NX8, and SolidWorks 2013, Service Pack 1. Now what I'm going to do is show you the configurations of this machine right quick, and then we'll step back through each one of these so you can see the results instead of putting up a separate HTML document. And then that way, at your convenience, you can step through this, see what's going on, and freeze it wherever you want in the video to see what's going on. I thought the Tesla coil tower was kind of cool, but that bug, man, that was wicked. Okay, I'm going to zoom in on this. We'll look at the hardware configuration. Now this shows the graphics hardware configuration. The rendering resolution 1900 by 1060, the desktop DPI 120, and the graphics accelerator, the AMD Radeon Pro WX 7100. Shows the driver version, shows the display resolution, doesn't say display size, shows the refresh rate 60 Hz. Now our broadcast normally is 1080i 59.94, and that's very important for us for stuff we do behind the scenes that I'll get to some other time, but it's important to know that what we shoot is 1080i 59.94, but what comes out of that video card is 60 Hz. If we looked at the properties for the video card in Windows, 60 Hz is what we'd see. That's what it reports. Display name, generic plug-and-play monitor. We're on a ViewSonic monitor. I don't have any special driver installed for it. And the system hardware, this is the MSI motherboard. This is the model MS7A31. Doesn't show a serial number. Shows the BIOS, AMI, BIOS version 1.4, and the version 107.2009, and the SimBIOS version 140. And the BIOS that's in there is the BIOS that we used when we built the machine. Right now it ain't broke. We're not going to fix it. The other BIOS updates that deal with some of these issues with Spectre, we haven't dealt with that yet. So I'm just showing you where the BIOS is at and where the technology is at right now, and everything works. Processor type, this is the AMD Ryzen 7 1800X, 8-core, 16 threads. I think that is so cool. Processor base frequency, number of populated sockets, 1 socket. Number of physical cores per processor socket, 8, and number of cores per processor socket, logical cores, 16. So 8 cores, 16 threads, and it says number of processor threads per core, 2. Shows the L1, L2, and L3 cache. Memory is identified, system memory correct, 32 gigs. It says memory types DDR3. It is not, it's DDR4. Shows the memory configuration, 2 16 gig sticks, that's correct. Shows a disk drive, shows a second disk drive, and then it shows the third disk drive. There's a Western Digital 2 terabyte, a Western Digital 5 terabyte, and then the Samsung SSD 960 NVMe. That's a little stick of chewing gum. Shows the capacity, shows the operating system, Windows 10, 64-bit. Submission details, official run. Test date 1/25/2018. System customization, supplier comments. So that's pretty much it for the system. So I'm going to go back to the top of this document, and we'll click on each one of these. And let you see each one of these screens. Okay, so for the view set for 3ds Max, we'll click on that. You'll be able to see this report. So let's get this down. Test 1, Test 2, all the way through Test 11. Shows the weight in percentage, which is pretty constant until the end, and shows the frames per second. Okay, now we'll go to the next one. Visual quality screen captures. Shows the tests. ViewPerf 12.1 screen captures. The images below are captured automatically by ViewPerf during each test for the purpose of visual quality assessment and verification. The pictures are in PNG format, which uses lossless compression. Let me just zoom out of that so I can read it in one shot. And supports up to 16 bits per color component, but which some browsers may require a plugin to view correctly. These images are provided for comparison purposes and are not guaranteed to be representative of actual screen display. So you can see test 1, test 2. We can look at the full images, test 4, test 5, test 6, test 7. Those fish almost look like a coelacanth. Nine, 10, and 11. And I don't think there's any need to go back and see the full image. So back up to the top of this, I'm going to back out. We'll look at the raw log file. There's the numbers if you're interested. I'll leave that up for 7 seconds. We'll back out. We'll look at the raw result file. I'll leave that up for 7 seconds. Okay, back to the test. We'll back out of that test. Now let's go to CATIA. This is the CATIA report. I'm going to zoom in on that. Test 1 through 14, the weight percentage, the frame rates, and the weighted geometric mean 106.56. Now we'll go to the bottom of this. Visual quality screen captures. Test 1. I'll zoom out of this for just a second. The images below are captured automatically by ViewPerf during each test for the purposes of visual quality assessment and verification. The pictures are in PNG format, which uses lossless compression and supports up to 16 bits per color component, but which some browsers may require a plugin to view correctly. These images are provided for comparison purposes only, are not guaranteed to be representative of actual screen display. So I'll zoom back in. Test 1, test 2, test 3, test 4, test 5, test 6, test 7, test 8, test 9, test 10, 11, 12, 13, 14. And no need to see the full size images. So I'll zoom out. Back to the top. We'll back up. Raw log file. Scroll to the bottom of that. Scroll back to the top, back out. Now we'll look at the raw result file. Back out of that, back out of that. Now we'll go to number 3. And this is PTC Creo 2.0. 1900 by 1060. I'll zoom in on that. Test 1 through 13 shows the weight percentage and the frames per second. Weighted geometric mean 79.74. Visual quality screen captures. The images below are captured automatically by ViewPerf during each test for the purpose of visual quality assessment and verification. The pictures again are in PNG format, which uses lossless compression and supports up to 16 bits per color component, but which some browsers may require plug-in to view correctly. These images are provided for comparison purposes only, are not guaranteed to be representative of actual screen display. So test 1, I'll zoom in, make it a little easier for you to see them. Test 1, test 2, test 3, test 4, test 5, test 6, 7, test 8, test 9, test 10, test 11, test 12, test number 13. I'll zoom out, back up to the top. I'll back out, raw log file. Scroll to the end. And I'm leaving this up for those of you who want to see this and read this instead of putting it up on a web page. Now, some of you requested I will go back and take this and put it up as HTML if you'd prefer. But I'm doing it this way because, well, let's just say some changes that YouTube made. So I'm hoping this will work for you. They want our links to be internal. But for something like this, that's kind of silly. You need to see HTML. But I'm hoping these will do for what you want. So energy, geophysics volume rendering. Zoom in on that. 7 tests. Weight value pretty consistent in frames per second. Varied greatly. Weighted geometric mean 6.10. Okay, visual quality screen captures. I don't need to read that again, it's for the same thing. There's test 1, 2, 3, 4. These were like watching paint dry. 5, 6, and 7. I'll zoom out. Go back to the top, back out. Raw log file. Back out. Raw result file. back out of that test. We'll go to Maya. We'll zoom in on that one again. 1 through 6. The weight percent pretty consistent. Frame rate. Weighted geometric mean 69.97. So visual quality screen captures, raw log file, and raw result file. So we'll go look at this. Test number 1. I thought that was kind of neat looking. Different. Test 2, test 1, test 2, test 3, test 4, test 5, test 6. Zoom out, scroll up, back out, raw log file. And raw result file. Back out of that. Now we'll go to medical. MRI volume rendering. We'll zoom in on that. Test 1 through 10. The consistent weight percentage. Frame rates per second grade greatly, and the weighted geometric mean 44.04. Visual quality screen captures. Test number 1. I thought that was pretty wicked looking. Test number 2. Number 3. Number 4. Number 5. Number 6, it's a nasty looking bug. Number 7, number 8, number 9, number 10. I'll zoom out, scroll up, back out, raw log file. Back out, raw result file. Back out of that, back out of this. Now we're going to look at Showcase. This is Autodesk Showcase 2013. We'll zoom in. 4 tests. Weight percentage, frame rates per second. Weighted geometric mean 67.34. So we'll look at the visual quality screen captures, the raw log, and then the raw result file. So here we go with visual quality screen captures. Number 1, number 2, number 3, number 4. I'll zoom out, back to the top, back out, raw log file. And raw result file. Back out of that, we'll look at the Siemens PLM NX8. Zoom in. 10 tests. Weight percent varies greatly. Frame rates per second also varies greatly. The weighted geometric mean 114.85. Visual quality screen captures, raw log file, and raw result file. So we'll go through these. I hope being able to see all these will help you to determine as that we have tested this system, that you can test your own system and compare whatever results you're looking for to what you think you want to build, or if you want to buy a computer. But this way you'll know what we've built. These are the results we get as configured. And when we put this video up on YouTube, I'll put a description down there of the components that are in this machine. Test number 5, test number 6, number 7, number 8, number 9, number 10. I'll zoom out, scroll back to the top, back out, raw log file. Back out, raw result file. Back out that, back out, and the last one, which will be SolidWorks 2013 Service Pack 1. Let's zoom in on that. Test 1 through 11. The weight percent, the frame rates per second, and the weighted geometric mean 108.18%. And again, the 3 options: visual quality screen captures, raw log file, and raw result file. So we'll look at the visual quality screen captures. There'll be 11. Number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, and the Tesla coil, the Tesla tower coil, number 11. Zoom out, back to the top, back out, raw log file, we'll back out, raw result file, we'll back out of that, back out of that. That concludes SPECviewperf 12.1 diagnostics and testing. And again, this is the system configuration in this computer for anyone that's interested. So, hope you found this useful. We're going to put this video up, a little bit of talking at the beginning, a little bit of talking to me right now at the end. And what I'll say is I hope this helps you, whether you're thinking about building or buying a computer, if you're looking at the specs, because we think this is bang for the bucks. When we built this, and this has the MSI motherboard with the AMD Radeon 7 1800X in it, which is 8 cores, 16 threads. Love it. Wouldn't build anything slower. And we also put the AMD Radeon Pro WX 7100 video card in here. We've been running it with several monitors. In the configuration with our video switch, we normally run 2. Another test we're going to do later, we'll be running 3 monitors. And I'll show you some of the adapters and stuff in those other videos we're doing. But this video is as a result of a question we had about this particular configuration. And if any of you other folks out there watching this have a question, I'm going to show you this. Again, this is from the question that we had on this particular video. about the AMD Ryzen WX 7100 and the Ryzen 1800X, where we did rendering and Cinebench results. Now, when we did that, that was live at the meeting and it was appropriate for that. And this is in regards to the question that Hellaptop had asked. And I'm going to zoom in on that. And I want to thank him for that question because I hadn't thought about running the test. I said, can you possibly make a video with SPECviewperf 12, a benchmark of your system? And I said, yeah, be glad to. So we've got the results of that test that we're going to be posting. But the HTML I'm not going to put up right now as a result of some new information that YouTube put out. But if I get the request specifically for the HTML, then I'll do it, because it's all about what we need to do as users, bang for the buck, and what we build or buy, and myself am here to do, is to help you to make smarter decisions whether you want to build or buy a computer and what components you want to use. Because it's always about, price and performance. What's it going to cost me and how much performance do I get? Right now I love the Ryzen, the video card. I wish it rendered faster. I render video with it. I don't do a lot of the kind of rendering that the SPECviewperf does. But if I did, I'm impressed. So I hope this helps you. Thanks for watching. Appreciate it if you'd subscribe, and thumbs up would also be appreciated. Thanks for joining us. We'll see you in the next video. Have a great day.